So other questions? High-low issues?
Yeah, no, I have a question.
Okay.
So I wrote my program and then I went back through and I realized that I should be getting it should be scanning for one character. I don't know if we went over how to do that.
Are we talking about ODP?
No, the actual program, PA3.
PA3, okay.
For the L, C, or H.
Right.
You're just scanning for the character.
Yeah. So if you say read -n1 in the name of a variable, it will come back as soon as you type one key.
Yeah.
Right, so I can hit a Y and I don't have to hit an enter, it just came back right away. And if I echo answer, it's equal to that Y. So read -n1 is your key. Mm-hmm. And you can use other numbers if you wanted to read 3 characters. Right, it'll come back after 3. Zero doesn't work. Other high-low issues? Yeah.
How far are you going to take for the highest number?
Oh, probably like 1,000. I'm not going to do something ridiculous like 20-digit numbers.
Better die than like.
Yeah, if you put in a number bigger than 2 billion, it's going to get weird. So, but I'm not going to do that. And I said you can assume it's a positive integer, right? So I won't try negatives. I won't try text. All right, so let's talk about the ODP. So your goal here is to write a calculator function that takes in a string which represents a simple arithmetic expression, and your function returns an integer, which is the value of that function's, of that string's evaluation. And everything here is integer based, okay, so you don't have to deal with fractions. And the strings that it understands are very limited in scope. So it's basically something like 23 plus 11. And your first number could be negative, so this is also legal, right, which is a potential complication. And this is also legal, because negative 23 is an integer, right? But no parentheses, no weird, funny business. And you want to use scanf in here, and the pattern you want to use is %d, %c, %d. Okay? And if your program is coming out more than, say 15 or 20 lines of code, you're probably doing more work than I intended you to do. So here's the real workhorse. So do scanf with a %d, %c, %d. Okay, where previously, oh, I thought you said string.
Oh.
All right, so num1, num2 are integers, char2 is an op. So scanf, whatever string you're trying to parse, %d, %c, %d, integer, character, integer, and then the address of those variables that you want to store the results in. And pick up the return value, okay, RET. And let's play with this a moment. Okay, classic test code. So this is the thing that we're trying to understand is the behavior of this scanf. So I've got the scanf, right, that we just wrote down on paper. And let's just print out the results of doing that. Let's print out the return value that scanf itself returns, and then the values of num1 and num2, and then the value of that operator. And then putting it in angle brackets in case it's a space, so we can tell it's a space. And we'll just print those out, right? So anytime you're trying to work with a function, a set of syntax, something like that, right? Make yourself some test code and just exercise the heck out of it. Just run this thing like a million different ways until you have a really, really high confidence that you understand, in this case, what scanf is doing with this pattern. So if I say 23 plus 7, oh, I knew it wasn't going to be that easy, because scan is an alias for me for using my scanner. All right, so 23 plus 7. So scanf returned a 3. My numbers were 23 and 7. My operator was plus. That's kind of what we were hoping for. 23 plus -7 also seems to work. It parsed 3 things. That's what the return value was. My numbers were 23 and -7. If I do -7 minus -7, my first number is -2, my second number is -7, my operator is minus. So far so good. Let's try something totally weird. So what do you think this is going to give us? What'll num1 be?
Error. Well, it's going to be a return -2, -1.
Well, this is the return from scanf.
Yeah.
Okay. So is it going to match that first %d?
Yeah.
Okay. So what'll num1 be equal to?
-7.
-7. Will it match the %c?
Yes.
Okay. So what'll op be equal to?
Negative.
Okay. And then will it match the second %d? Only if -7 is an integer, which it's not. So it won't change the value of num2. It will have matched 2 things, so the return value should be 2, right? Because return value is the number of things that it parses, right? So ret was 2, num1 and op were set up as we wanted, num2 happened to be a 0. What about that? Definitely no.
Return 0, right?
Yeah, return is 0 because it scanned 0 things. If you have an empty line, and it's not actually empty, it has a new line, but it's only got white space in it, then scanf returns a -1. That's the weird special code for didn't match anything. All right, what about here?
Return 1.
Yep, that'll return 1 because it'll match the first integer, which will go into num1, but then it actually, that was sneaky. So it matched the 1, 2, that's an integer, and then we tried to pick up a single character. And remember, fget puts a new line on the end of our input, so it matched the the \n as the operator. So that's why the operator is a new line, and then it actually returned a 2 because it scanned integer and an operator character. So that's a weird one. A bunch of spaces. That's your -1. So if you believe you understand how scanf works, that does most of the work for the ODP, right? So the actual assignment is to scan your string. If it does not scan successfully, meaning if scanf does not return a 3, then your function returns a -1. Okay, and it says this was not in the form of integer, character, integer. If it does return, if scanf does return a 3, right, for example, right here, scanf returns a 3. Because we said match an integer followed by a character followed by an integer. Well, that's what it did. So this parses successfully according to that pattern %d, %c, %d. But the problem is that h is not one of the operators that we're actually worried about. So if it parses successfully but the operator is not plus, minus, star, or slash, then your function returns a -2. Otherwise, your function should return the actual value of this expression. And so how do you do that? Well, you know what the first number is, you know what the second number is, you know what the operator is. So it's 4 possible cases. If your operator is a plus, return num1 plus num2. If it's minus, return num1 minus num2, and so on. And let the system do the work for you, right? If you've got 9 divided by 8, just return 9/8. Right, and since these are integers, it'll return a 1. And so there's some test cases here where the thing inside angle brackets, not counting the angle brackets, is a string being passed to the function, and then it shows you what the function returns if it's working correctly. So 9 plus 9 is 18, that's clear. 9 equals 8 equals not a valid operator, so it returns a -2. Yeah. HA plus HO returns -1 because it's not a valid syntax. It's not an integer, character integer. 9/8 is 1 because it's 1.125, which rounds down. 8/9 returns 0 because it's 0.888, and it rounds down. And it'll do the rounding for you. So make sure your subtractions do the right thing. 9 minus 8 is 1. 8 minus 9 should be -1.
If we were actually using this function and the result of the math was -1 or -2, would that cause an error? Because it would think that it...
What do you mean?
Well, I assume that you're returning -1 to say, like, you know...
Oh, as a flag? Yeah, it's a silly flag because we can't return the value of -1. So if you did 2 minus 3, it would return -1. We wouldn't know if it was an error or not. So yeah, it's a weak function. But this is the free version of the function. All right, and I won't give you numbers that are ridiculously big with like 20 digits in them or something, right? So you don't have to do any heavier lifting than what scanf is capable of processing with that pattern. So it's not intended to be, 100 lines of code here. It's really just sort of pulling in a string, using scanf, looking at the return value, looking at the values you saved, making a switch statement, and figuring out the value of the expression. So write your calc function, test it with your own test program, right? And you can use something like this, if you like, that instead of, calling scanf, just pass a string to your calc function and prints out the return value. That's perfectly fine. And then once you think it works, go ahead and compile your calc function, link it in with the test bed, which is that file and /temp, and then assess calc.c. There's a typo. All right, makes sense? Yeah.
Other than a bunch of if-else statements for checking the operators, is there a way that you can use that code to insert yourself into the code? So that you would have like the character plus would become a part of the code. Is that possible?
That's a fun question. So, so is there a way to take that character and somehow feed that into the code so it's actually evaluated as a character? It's hard to do in C. It's easy to do in assembly language, right? So think pick processor maybe, or even x86. We could take the ASCII code for that character and use it to generate the binary machine code for an add or a subtract or a multiply, and then just write that into memory wherever the next instruction is that we're about to execute, and we could actually modify the opcode that way. So that's self-modifying code, it's a thing. But you can't really self-modify in C because it's compiled. I mean, we could do the same thing, but it gets really ugly. But it's a whole interesting sub-area of programming, is the idea of programs that can modify themselves. And we do this even in modern operating systems. The operating system basically modifies itself in some way when it's running your program for you. Right? It's taking a section of memory that it just wrote data into, and now it's executing it as code. So this is launching point for my research in cell matrix and stuff. So don't get me started. All right, any other questions? As usual, your calc function does not produce any printed output, right? If you put print statements in there to debug, that's good, but before you actually assess, take those out. And don't have it wait for input from standard in either. All right, so let's talk about the life of scanf a little bit. So this was our argument for scanf, %d, %c, %d, and we're trying to store the matching patterns in num1 operator and num2. So my question for you is, how does scanf do this? How does it go through an array of characters and turn it into a pair of integers and an operator? What would the algorithm for that look like potentially? And let me break it into pieces for you. Suppose this is your input string, and your goal is to just break it into 3 pieces. A string of characters here, a single character here, and a string of characters here. And forget about turning those characters into integers for a moment. Let's just break this into 3 substrings. So what would your algorithm look like to do that sort of splitting of this into 3 pieces, where the split is made based on some operator? So let's start talking about some pseudocode or some ideas for an algorithm for this.
You just loop through like each element of the array and check if each element is like 0, 1, 2, 3 or whatever.
Mm-hmm.
And you just do that until it's not 0, 1, 2, or 3.
Okay.
Once it's not, you check the not part.
Okay.
And see what that is, I guess.
Okay.
say probably pretty similar to that. Just loop through each character, check if it's a numerical value. If it's a
Okay.
numerical value, find all numerical values after that, and then put it into an integer, and then go through until you find the character, and then get all characters after that, and put it into a string array.
Okay.
Then you just do that for each.
Okay. So let's write a for loop. So this is string. So for I equals 0 to, how big do we want I to go to get through this whole string? Well, in general. String length? So for I equals 0 to string length of string, what do you think about that? So if this is our string over here on the left, what is string length going to return?
5.
It's going to return 5. Okay, so this is element 0, 1, 2, 3, 4. Element 5 is the null terminator. So we probably want to go up to string length -1. Right? Same way if we do a inequality, we usually go I equals 0, I less than string length, which is the same thing as less than or equal to string length -1. So this will march us through our string. And let's take the ith character and throw that in a variable called c. So c is going to be a 2, and then a 3, and then a plus, and then a 1, and then a 7. So what should we do with c now? We talked about saving it into a string array.
You can save string or a C into a string array that represents that first number.
Okay, so let's make a big wide string, 100 characters, called num1. And so we want to save C into that array. Where should we save it? Always?
At num0, there isn't another.
No, you're right.
Yeah, num0 if there's another integer after it.
Okay. So there's a few things we could do here, right? So last week you were doing stuff on the board, and there was this idea of having multiple pointers, right? I is moving you through the input string. We could have another pointer that moves you through the output string, right? So we could have something like num1 position equals 0. And now we could say num1 position equals C. And after we've stored character C at that position, we want to increment that position, right? So we could throw a plus plus in here, or we could write a separate increment statement. And we want to basically repeat this up to a point. So where do we stop doing this? Yeah, when it's not a 0 or a 1 or a 2 or something like that. So we can say if C equals 0 or C equals 1 or alright, we can make this big compound if statement to see if C is a digit. And that's not bad, that works. But for like, is C a letter, it gets really big. We can cheat. And play with ASCII codes directly. So if C's ASCII code is bigger than or equal to the ASCII code for a 0 and less than or equal to the code for a 9, right, that makes it a digit. But don't do those things. Go to the manual pages for isDigit or isAlpha or isAlphnum or any of these things. And there are built-in functions for doing this for you. So in particular, there's an isDigit over here on the right. And isDigit takes a character. It's an integer. Characters are usually stored as integers or treated as integers when we pass them to functions. And it returns an integer, which we can throw inside an if statement. So come down here for isDigit. I just missed it. So it checks for a digit 0 through 9. And the return values are non-zero if it falls into the tested class and 0 if not. So if you put this inside an if statement, you can say something like if isDigit C. And the body of this if statement will be executed if it is a digit. Or you could say if not isDigit. And it'll execute this if it's not a digit. All right, so we can do this as long as this character is a digit. We can store it into num1. Otherwise, the character we're looking at position I is not a digit. So what do we do in that case?
Run the loop for character.
Say again?
Run the loop for character for the next 4% C instead.
Well, okay, so we need to store a character. So suppose we do this on this string over here. So we've got num1 pos, we've got num1, we've got I. So num1 pos is 0. Num1 is, we don't know what it is. We've got I is 0. So C is our first character, that's a 2. It's a digit, so we're going to take num1 0 and set that equal to C. And we're going to increment num1 pos. We're going to go back to our loop. I is going to be 1, C is going to be character 1, which is a 3. 3 is a digit, so we're going to store that in position 1. And we're going to increment num1 pos. We're going to go back to the top of the loop. I is going to be equal to a 2. C is going to be character 2. That's not a digit. Okay, so this is our current setup of the machine. And we already have this thing that's not part of that first number in a character variable C. So we could probably do something like just op equals C, right? So save the operator.
As is, wouldn't the code also, though, if it was a negative number as your first one, go straight to op equals C?
Yes, so that's going to be a complication. All right, what do we have to do with num1 here, just to be clean? as a string, what does num1 look like right now?
What do you think about
Got to throw a null terminator on. So since we're in here, we want to throw a null terminator. Well, num1 pos always shows me the next position that I want to write to, so we could actually say num1 bracket num1 pos equals null terminator. So now we got a null. So that's all set. And our operator's set, and our num1 is set. But yeah, so there's this additional issue that if our number was actually negative, right, this code won't work because the first time through minus is not a digit. Our operator will be C, our num1 will be an empty string. So how do we handle something like that in general? This is the $64,000 question. The whole key here is state, as in 250 state machines. The whole key is to know that this set of code can run under different conditions, right? And our state is basically a way to record the conditions that this code is running under. So there's something special that happens the first time through this loop. The first time through, if that character is a minus or a plus, we treat it as part of the number. After that, if the character is not a digit, it's an operator. But the very first time through, when we look at the very first character, character 0, if the character is not a digit, but it's a plus or a minus, we treat it as part of the number. So we need to have some notion of state, and we can have a variable called state, and we can set it to different values. State 1 says we're looking at the first character of our first integer. And if we're in state 1, we do something a little more forgiving here, right? If it's a digit or it's a plus or a minus, then we go ahead and we copy it to our number. Otherwise, it becomes an operator. And then we go on to state 2. And in state 2, it's got to be a digit, right? So in state 2, we go on, we get to the plus sign. There's our plus, we throw it into the operator. Well, what's going to happen the next time through the loop? We want to look for digits again. But we don't want to save them in num1, we want to save them in num2. So we go to a new state. And now this becomes an if statement. If we're in state 1, save this in num1. And if we're in state 3, save it in num2. And we need a num2 pos that we initialize to 0. And we increment when we do our save. And if we're in state 3, and we get to something that's not a digit, then we're done, right? We hit that second %d, we hit the end of that integer, and now we can null terminate num2, and we're done with our scanf. Well, we can also do things like (17 times -5). So when we start parsing for the second %d, we also need a separate state. First time through, we need to say, okay, if it's a digit or if it's a plus or a minus, we'll add it as part of the number. Otherwise, it has to be a digit. So we've got several states in here. So scanf is in some ways a really, really big, complex state machine. And we control the way it moves from state to state and what it does in those states with this expression that we give it as its second argument. So in 215, pretty close to the end of the course, we'll be talking about languages and grammars and parsing and state machines. And we'll see how these tie into one another. And this idea of parsing input, parsing text to break it into pieces is kind of quintessential state machine. And we'll see that a few different ways in 215. And we'll play with this some in 222. We'll actually make code that actually evaluates expressions based on how it parses. So scanf is doing a lot of work for you, right? Which is a good thing. Let me have you think about one other thing. Suppose that we've done what we just described and we've split your string into a few pieces. And now we have a character array containing 3 characters, a 4, a 1, and a 7. And we want to write a piece of code that turns that into an integer, 417, without using scanf. Right? So how would you take a string of characters and turn it into an actual integer value that matches it?
There's in the string library, there's a function that automatically does it.
No, we can't use that. Got to do it ourselves.
Alright.
Use some of ASCII codes.
Could be part of it, sure. So we could use ASCII codes to recognize that this is the integer 4, this is 1, this is 7.
And then set an integer equal to each of those ASCII codes.
So we got one integer on the output, so we can't set it equal to 3 things. But how do we combine the 4 and the 1 and the 7 to get 417?
Make it like sort of like the base 10 numbers, and still
Yeah.
treat the first number as 4 times
Yep.
100.
That's exactly what we can do. So we can count and see that there's 3 characters here, which means this is the 10 to the 0, 10 to the 1, 10 to the 2 position. So we could have some counter that's equal to 2. And when we take this first character, we can change that to the integer 4 by looking at its ASCII code, and then say 4 times 10 squared, and have a running sum that starts at 0. Add that number to our running sum. Move to the second character, decrement this to a 1, and then add that second character times 10 to the first. Move to the third character, decrement this to a 0, and then add 7 times 10 to the 0. Move to the fourth character, that's the null terminator, we're done. And so our sum will be 400 plus 10 plus 7, 417. And that's how we do this, right? When we look at a number on a piece of paper, it's a bunch of characters. When we try to translate it into an integer in our heads, we're basically doing the same thing. We're doing 400 plus 10 plus 7. There's another way to do this. We can start off with our sum equal to 4. If there's another digit, multiply your sum by 10 and add that second digit. And then if there's another digit, multiply your sum by 10 and add that next digit. And there's no more digits, so we're done. So here sum's equal to 4, multiply by 10 it's 40, add 1 it's 41, multiply by 10 it's 410, add 7 it's 417. And that just saves you from having to calculate powers of 10, because we're basically calculating it by doing this multiplication. That's a slick little polynomial evaluation algorithm. All right, so the reason for working through this, right, is not to come up with the code for scanf, right, because that's already been written. We can download it, right? It's the process of thinking about what kinds of things we need to do these functions that can be useful. And the main idea here is the idea of state, right, of having one for loop, for example, that does different things depending on what's happened in the past. And some of this business of dealing with characters, and in particular using things like isDigit instead of ASCII codes if we can. All right. So let's change gears here. So I want to take a couple of days and I want to talk about regular expressions. And I want to do this inside VI because VI is a handy platform for experimenting with things like this. So how do we search for something inside VI? Like we want to find the first instance of the word alias. Not that I know of. No. Oh, that sounds familiar. So slash, right? So you can type slash and then type something in, and it will bring you down to, I have my exclamation point, slash and a pattern, and it will bring you down to the first spot in your file where it finds that word, which in this case was aliases. And if you say n, it will search for the next occurrence of whatever you just searched for. So I can just hit an n, and it finds any line that has the word alias in it. And if you hit a shift n, it searches in the opposite direction, so I can search up. And if you go past the end of the file, it'll wrap around and it'll tell you hit the top, continuing at the bottom, or hit the bottom, continuing at the top. So when we say slash, we can follow this with a set of characters, but it can more generally be some sort of pattern. Okay, so our patterns could be regular characters, but they can also include a period, which matches any character. And character could be a letter, could be a digit, could be a punctuation, could be a space. It's basically any character. It's not just A through Z. We can use a star, which means 0 or more of the previous character. So let's search for a 0, right? And it finds a 0 right here. And if I say, let's find the next occurrence of a 0, it picks up that next 0. And if I say, let's find the next occurrence of a 0, it picks up that 0. Now if I say slash 0, 0, that says look for a 0 followed by another 0. Well, it brings me right down here in my 1000, and it's matching that 0 and the 0 after it. Okay, so if I say next, find another pattern of 0, 0, it's already gobbled up this 0 right here. Right, that's the pattern that it just matched. So it's not going to see this 0. It's going to come all the way down here, and it's going to pick up these two zeros as the next occurrence. And then there's another 0, 0, and so on. Now if I do something like this, there's our first 0, 0, there's our second, there's another, there's another, there's another. Okay, so if I say, let's search for 0 star, that says find 0 or more occurrences of, in this case, a 0, right? And there's one right there. There's a spot in my file where there's 0 occurrences of a 0. And if I say next, there's another one, and there's another. So that's a little silly. If I search for 0, 0 star, that'll search for a 0 followed by 0 or more occurrences of a 0. So that will match right here, right? So it matches that 0 followed by, in this case, 2 occurrences of a 0. So this actually eats that entire set of 3 zeros. And now if I search for the pattern again, it comes down here. And the pattern that I actually matched was this 0 followed by 1, 2, 3, 4, 5, 6 zeros. So now if I say find me another 0 followed by 0 or more zeros, it jumps down here. All right, we are out of time. But we're going to build on this. And we're going to learn how to match patterns, but then we're going to learn how to substitute patterns, and that's really what we want to do with regular expressions. So we'll dig into that tomorrow.
See what visualize it.